Hello, am I audible?
Yes, you are audible.
Okay, so I think Sunil asked in which format students are supposed to submit their assignments. So I think we are fine with both LaTeX or handwritten assignments. As long as the assignment submitted has everything written clearly, which is readable, we are okay with both handwritten or LaTeX assignments. Submit it in the PDF format in the portal as instructed, and make sure whatever you have written is visible in the PDF. And you are submitting all the pages of whatever you have written, because you can submit it only once and no further sharing of PDF would be accepted. I hope that answers your question, Sunil.
Yes, ma'am.
Okay. Uh, Hello. I just wanted to tell you that Professor Patil will be joining soon. Meanwhile, how many of you have actually gone through the first week's lectures? At least listen to them. And there are any doubts, what are the difficulties which you are facing, the general difficulties? Or it is easy to follow and easy to understand the concepts which are covered. If you have any doubts or any comments regarding that, please also let us know that as well in the comments or by unmuting yourself so that it will be helpful for us as well.
So I have a doubt.
Yes.
So if we need to check the well-definedness of map,
Sorry, sir.
of a map, am I audible?
Yes.
So suppose A is an ideal in a ring A and B is ideal in ring B. So A mod A cross B mod B to some ring C. If I need to check the well-definedness of this map, so the elements are pair of uh, equivalence classes. Means, so can I check one, like fixing one and taking different representative of the other one, like one by one, if I check, does this imply the well-definedness of overall? Means, or like I want to know how to check well-definedness where there are two quotients together, like product of two quotient rings.
The map starts from product of two quotient ring and the codomain is?
Codomain is some other ring where so if I need to define a map, so I need to check, yeah, the representatives may change. So suppose my first representative is A and B, small a and small b. So the class of A, comma class of B goes to some element. So the same element can be represented C bar, class of C and class of D. So my question is, can I take the second, the B and D, can I take as same, like class of A, class of B, this element goes to some the image element, and I'm just changing the representative of the first coordinate, the first ring, and the fixing the second, the B, and now checking the well-definedness. And in the second step, I'll fix the first one and change the second one and check the well-definedness. If these two conditions satisfies, does this imply the map overall is well-defined?
Hello.
Hello, namaskar, sir.
Namaskar. Sorry, it was some trouble with my computer and then laptop also. So it got delayed. I'm sorry. Okay, carry on.
So, sir, I have a doubt. Suppose I have two quotient rings, uh,
Uh,
A mod A and B mod B. So, if I need to check the well-definedness of product of two quotient rings to some other ring,
I am not.
so
I am not able to understand your question.
okay, sir.
Sir,
So I have two
Siddhi, can
quotient
you
rings.
understand his question?
yes, sir, I will explain you his question. So he is saying that suppose small a is some ideal in ring A and
Yes.
small b is some ideal in ring B, and
Yes.
he wants to define a map from A quotient ideal A product B quotient ideal B
Yes.
uh, uh, to some ring. And
Hmm.
he's saying how to check well-definedness of this map because we have quotient over different ideals in both the components of the product. So how to check the well-definedness
So
of such a map?
A cross ideal A and A by ideal A and B A by ideal B.
Yes, A quotient ideal A, product B quotient ideal B.
And then map is going from this to somewhere, right?
Yes, sir.
Then you have to check well-definedness in the both the components. See, when you want to define a map from the product, that means you should have a map from each one of them, and then you define the product map, right?
Uh, so, sir, my doubt is if I check well-definedness for each component by fixing
Hmm.
the other component, then
And
does this imply that the product is also well-defined?
you have to define the product also, no?
Uh, like I'm taking different representative of the first quotient ring and the fixing a component of
See,
second quotient.
rather than talking abstractly, you can start with one counter example, concrete example. You understand? Hello? Hello? Can you
Yes,
hear?
sir.
See, suppose you want to define a map from Z mod M cross Z mod N to some ring A, right?
Yes, sir.
That is what your problem is, right?
Yes.
So first you define there is a map from Z to A first, right?
Yes.
And then check that it goes mod M. Similarly, you check the map from Z mod N to A. And then you want to define now a map from the product. Now you have to give a definition of the how will you define the product from product to the ring A. See, there are three steps in one. How do you get back to this question? Hello?
Yes, sir. So, sir, I wanted to know that A mod, if M is an A module, if
Hmm?
if M is an A module, then M mod MM is also an A mod M module.
M mod?
M mod that sir, M is a maximal ideal in ring A, then
Hmm?
MM will be a submodule of M, then M
Hmm?
mod MM, I'm
Hmm?
sorry, sir, M is repeating. So this will be a module as an A mod M module.
Yes.
It is A module, it is clear. So when it is A mod M module, then I need to check the map A mod M cross M mod MM to M mod MM.
Hmm.
So there will be two questions are coming in this map. So I
Yes.
wanted to know if I check the well-definedness for each component by fixing the other
Yes.
components.
Yes.
So the both step, if this map is well defined, then does this imply that by changing simultaneously both components, do I have to, is there something
But
more
then,
or
what is your map from the product to the other module?
sir, A bar M bar goes to A M bar?
See, unless you write it on the, is there a possibility to write on the board? I am not able to understand your question. And Siddhi, can you understand?
Yes, sir. I mean, I can understand what is his problem. Where he is having the doubt that I think he wants to say that when we fix one component and
Hmm.
then we are verifying it on other component,
Hmm.
we are getting well-definedness of a
Yes.
map collectively. So,
Yes.
for example, if he is saying A comma B goes to somewhere and A dash being some other representative, then A dash comma B is also going to that same point. That
Yes.
shows that the well-definedness in the first component. Similarly, we can do a comma b dash, and
Yes.
we get some other some, and we get the well-definedness on the second component. Then
Yes.
he's saying just checking this. That's it. That we are just checking the we have map defined already. We are
Hmm.
checking it on each component, and we are getting well-definedness at each component. Is it enough to declare that map is well-defined on the product?
But you know what kind of a map it is? That is will also depend on that, no?
Yes,
See, if
sir.
I,
So in
see,
general, what he is asking is not true, sir, actually.
no, in general it is not true, but it will
Yes.
depend on what is the map from the product to whatever.
Yes, sir.
See, if it is a sum or product or combination and things like that.
Yes.
Okay, sir. In general,
So,
I wanted to ask if
no,
it
in
is
general, that statement is not true.
okay, sir.
In
Okay, ma'am.
the generality you are asking is not true. It will also depend on the what is the map on the product.
Okay, sir.
Yes. Yeah. How many people have joined? 7. Okay. So any other question?
Excuse me, sir.
Yes.
Uh, Sir, I have the little bit doubt in the
Can you
spectrum
also
of.
play? Can you also please let me know where are you from?
Sir, I am from Gorakhpur, sir.
Gorakhpur. Your parent
UP.
institution. Huh? No, no. Gorakhpur. I
Uh,
know where it is.
yes, sir.
No, parent institution, university or college or.
No. I'm not. I'm just in the inter college. Just
Hmm.
to understand the subjects, no field theory and this all commutative algebra. Actually,
Hmm.
I've done MSc also. I'm a teacher, but actually in the school times, that much concepts are not very much clear. So again, I've started to gone through this. I've came to know the NAPTEL site, and I have already done the two courses here: linear algebra and number theory, and very well it has been explained. And so now I've tried to explore this algebra part also. So that's why I've joined this course, sir. And I
Okay.
have
So
this I filled the form for the examination also. So last two also I've given the examination and I've scored good in that also. So concepts are very much clear because what sir you people are explaining, na, the things we are understanding, and we are coming to know that okay, what is the application, how it is happening, everything is means very much clear. In our college life, what we did, na, actually just we have gone through the theorems and just we have practiced 3 4 times that part, and just we have written the exams. So however we have got the degree, but now I wanted to know that actually what we are seeing in this. So that's why
hmm.
I want to explore the subject, sir, as an
Okay.
interest.
That's good. But are you a lecturer there, or you are teaching, or you are a what
Teacher,
is
I'm teacher.
your
I'm teacher,
teach?
sir.
You're teaching to what level?
Sir,
College.
12th school level, 11th, 12th school level.
Hmm. But then, mm, Anyway, so how much are you understanding in the lectures here?
I'm understanding that part. Like mostly it is like what I come to know that mostly it is of the field theory part, and it is like basis and expansion and the polynomial rings, something like and of that part. So I'm understanding that part, and a little bit I have the doubt here, like what the prime spectrum and maximal spectrum. There is a difference that what you have given in that notes. Like
Okay.
so, I want to clarify that one.
Okay. So that I will clarify right now.
Yeah,
So
sir. Yeah.
when you have a commutative ring, see all our rings which we consider in this course are commutative. So when you have commutative ring, there are prime ideals and there are maximal ideals. This concept do you understand?
Yes, sir.
Concept of a
Yeah.
prime ideal.
Yeah. Yeah.
What is that?
So prime ideals means when we go with the like suppose with Z mod prime or some parts like set of all the ideals in that P. If like
No,
when
no.
we say
See,
that,
what is your name? Satinder. Satinder, I
yes,
am
sir.
asking very simple question. When you have a commutative ring, what
Yeah.
what do you mean by prime ideal?
Prime ideal means ki if I'll take the element in that particular element and one more,
Okay.
so both the part will belong to in that only
Okay.
the same set.
So no, let us go. Let us. Your concepts are not clear. Let me give you a simple ring of integers.
Okay.
Can you tell me prime ideal in this
Uh,
concretely?
so I have to see. I have to go with the Z mod P. There I can find the prime ideals like
What is
with
P?
mod
What is P? What is P?
prime numbers.
And then why did you pick a prime number?
Suppose if I'll go with the mod Z2, so I'll take 0 and 1.
So
So 0 and 1 will be the prime ideal.
no.
Now,
See, your one is not a prime ideal. See, you
okay,
are
elements,
not understanding.
elements. It is the elements of
I am
that
asking
part.
very I am asking very simple question. What do you mean by a prime ideal?
Okay,
First of all, you tell me what do you mean by ideal?
okay. Ideal is the like subset of the ring. So
Hmm.
when we are going to multiply by any element, so that particular like any element belongs to the
Why don't
superset
you
of that.
talk concretely? See, your problem is you just talk generally.
Okay. So
So, man, so
ideal
tell me
is
first of all, what do you mean by ideal in a ring?
ideal is a ring in a ring is a subset of that ring, particular
Hmm.
subset.
Yes.
Now, if I'll take any element that not belongs to this subset, maybe the superset, maybe that the superset of the ring, and then I'll multiply with the this subset. That
No. No,
means
I
operation. What?
see. This course is a far long way to go. This is
Oh,
just a
yes, I am.
beginning.
Yeah, yeah.
See,
I'm
I will
understanding
tell
that.
you a definition of ideal. What one should tell.
Yeah, yeah.
A is a ring, and A is a subset of, or let me call it I. I is a subset of A. Then that we call it a ideal when it is closed under addition. If that means if A and B are elements in I, then A plus B is also in I. That is one. And then whenever R is arbitrary element in the ring and small a is arbitrary element is in I, then R times A is also there in I.
Yeah.
If
So
these two
this only I was.
conditions,
Yeah, yeah.
if these
This
two
only I was
conditions,
expecting.
so now that is an ideal. Now can you tell me, now continue in the same way. Can you tell me when do you say I is prime?
Uh, like what I am so far understanding, like prime ideal is that if I'll take a element in the subset of this, uh, and I'll find
What?
the product. Hello.
Hmm.
Yeah. So that if that product belongs to this subset, this implies that the both the elements will be from the same subset. It should be not from the set A. That only.
How can you expect both?
Or means any one. This one actually that much not. I think clear that part. Prime ideal and maximum ideal. So I'm understanding a little bit. Maximum ideal. So I'm understanding.
See, when you say little bit is not enough in mathematics.
Yes, sir, I know. So I've taken the field course of this one, NAPTEL course. One that is of ring and field theory also course I've taken, so that thoroughly I can understand each and every parts.
So you have taken NPTEL courses?
Yeah, both.
Which course you have taken?
So ring and field theory I've taken.
By
Then
whom? Who are the instructor?
it is from IIC Bangalore. Uh, Instructor Anantru, something like that. I have to see the name of the instructor, sir.
Okay.
It
Okay.
is from the same. Okay.
See, this course will be difficult for you with your background. Looks like that. I don't
Yeah.
want to discourage you, but the most important step is missing in your
Definitely, yes. Basics understanding
because
actually that I lack.
your background is not strong enough, and
Yeah, you're right, sir.
it is hazy. It is hazy. So you will
Yeah,
have to improve that, and it will take some time. Siddhi, you want to
yeah,
say
yeah.
something? Hello, Siddhi. Hello. 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 Anybody else has any some question or comments or suggestions?
I think Siddhi cannot hear me. I am Anubhav.
Sorry.
I can hear.
I yeah. Okay.
Siddhi, you want to say add something?
No, sir. That is, I do not want to add anything, please.
Okay. Anybody else want to ask any question? Who is Shiva here? How many people have joined?
Sir, actually, my name is Vijay Kumar Sharma. I use different ID, so I'm sorry for that. Sir, I have a doubt. You in your lecture, you said in integers as an as a Z module, the generating set. Uh,
Who is
uh,
talking? Who is talking?
Sir, my name is Vijay Kumar Sharma. I'm using a different email ID, so that is why it is showing Shiva, my nickname. So, may I ask the question, sir?
So, what is your question?
Sir, in integers, the single any singleton is linearly independent. Sorry, generating set. So you mentioned given any r in natural numbers, there exists a r number of means there exists a generating set, minimal generating set of r elements for every r in natural numbers. So I'm unable to find like for
Siddhi,
every
you
r.
understand his question? Hello?
Yes, sir. I think he's saying that in your lectures you said something like for every integer n, uh,
Hmm?
we can have we can have a generator, minimal generator of
Okay,
I-
so
of
let me please
what?
try.
In which
For
ring? In which ring?
in integers,
In integers.
integers
Yes.
as a z module.
Hmm.
So uh, you said one is generator, one is a
Hmm.
minimal generating set. If you take 2 and 3, that is also minimal generating set. And then you
Yes.
mentioned that it is possible to find for every natural number, take
Yes.
as large as possible, there exists a minimal generating set of.
So try for three. No. Now suppose you have given me for two. No. Two, three, and now you want three minimal, three generating set with three elements, and they are all just a minimal generating set. Can you think? In integers only, no?
Yes, sir.
Yes, can you think? See, rather than thinking abstractly, you have to come down to concrete situation and then ask questions.
Okay,
Suppose
sir.
you take 2, 3 and you want to join somebody else so that none of them can be dropped. Is it possible?
Okay, sir. Primes if I involve.
2, 3, 5, is it minimal generating set?
Yes, sir.
Huh?
Sir, 5 can be made from 2 and 3. 2 plus 3 is 5.
So it is not possible, right?
Not
5
possible.
is not the right candidate.
Yes.
So now think about this. This is very simple question. You just have to play with integers.
Okay, sir.
Okay.
Thank you.
Any other question?
Yes, sir, in equivalent conditions, when you say B is an A algebra,
You
A
are
and
the same person talking.
sir, yes, sir.
Yes. Tell me. You
A
see,
and
when you
equal.
ask
Okay,
ask questions in such a way that whoever you are asking, it should be
okay,
clearer to that person.
okay, sir.
Otherwise,
So,
you can't hope to get any help from anybody.
hmm.
Tell me.
Sir, let A and B be two rings.
Yes.
We say B as an A algebra.
Hmm.
If the definition of A algebra that you wrote
Yes.
would be a vector space.
Where is the
F among,
vector space coming?
sorry, B is an A module,
Hmm.
and B is a ring,
Hmm.
and should satisfy, and the operations scalar multiplication and ring multiplication
Hmm.
are compatible with each other.
Yes.
So this is the definition of B as an A algebra. The
Hmm.
equivalent definition you said, if there exists a map, if there is a ring homomorphism from ring
Hmm.
A to B, then also B can be seen as an A algebra, given that phi of A should be subset of center of B.
That is for when the ring is not commutative, right?
Okay,
See,
so
if the ring is commutative, suppose your ring is B was commutative, then this question will not arise. No, this will be automatic.
so the condition when in non-commutative ring, if we take, then
Hmm.
this condition we
Is
need
necessary. Is necessary.
necessary because of this compatible condition, right?
Yes. Yes.
Okay. For that purpose only, or it cannot be reduced. Means that has
Yes.
to.
Yes. Yes. For
Uh,
example, you can look at okay, do you know an example of a non-commutative ring?
yes, sir. I mean, uh,
Yes.
um,
Matrices or
yes, if dimension is bigger than equal to 2.
matrices over K, let us say. K is a field. Matrices over real numbers. This is a ring. So
Yes.
if you take a natural map R to MNA, MNR, what is the map? How do you give a
Uh,
map from R to MNR?
R2,
MNR.
sir, I can take a diagonal matrix. I can take
Which diagonal matrix? Scalar matrix, you mean?
Scalar matrix, yes, sir.
Yes.
Scalar matrix we can take.
So is it now the image goes in the center or not?
Yes, sir. It is in. Actually, these
Just
are the precisely the elements of center.
okay. Okay, fine. So therefore, MNR is a R algebra.
Yes, sir.
Okay. Okay. Anything else? Your name is Vijay Kumar.
Yes, sir. My name is Vijay Kumar.
From where you said?
I'm from Raurkela, Odisha. And
Raurkela. So you are a student or a teacher or what?
yes, sir. I'm a high school teacher.
And why do you want to attend such courses?
Actually, sir, in my master's, I had one course, Commutative Algebra. I got interested. I wanted to recall. I was not in touch for a long time in mathematics. So,
And who taught you that course?
sir, Professor Balwant Singh Baga.
Balwant Singh.
Yes, sir.
From it's Mumbai, no?
Yes, sir. I was a student in Center for Excellence in Basic Sciences.
CBS.
Yes, sir.
Okay. So you were a student there.
Yes, sir. I was a student there.
Yeah,
So,
Balwant Singh was my PhD advisor.
oh, okay, sir. Actually, he's like,
But this must be long back.
yes, sir. So I was not in touch with mathematics for a
No,
long time.
when were a student in CBS?
I was a 2013 to 18 batch. It was
2000.
a course 2013 to 18. It was 5 year integrated course.
Hmm.
So Professor Balwant sir taught us the commutative algebra and one advanced commutative algebra. The first part we ended with dimension theorem, and the second part the regular local rings we
Okay.
studied.
Okay.
Okay, thank you.
Yes. Yeah. Anybody else want to ask question? Anubhav. Hello, Anubhav.
Yes, sir. Yes,
How
sir.
are you? How are your exercises? These PMRF lectures.
Yes, sir. I took only one class.
Hmm.
Uh, it was fine. Uh, some of them were responding. I think 4 or 5 people were there.
Hmm. But
Uh,
none of the
they
one
are,
who came here. None of the one who came here, or
uh, yeah, I think some of them are here. I don't recall their names.
hmm.
Uh, therefore,
I think
maybe,
you should make it more interactive.
yeah, I am trying. I ask them questions. If
Hmm.
they have doubt, then only they respond,
No,
or
even
else,
see, getting a doubt is a very good thing, but when they try to tell you the doubt, they are not clear what they want to ask.
yeah,
That
I have noticed that. Yeah,
now, for example, today, so they were not clear what do they want to ask exactly, and that you should try to emphasize
yeah.
and so on. When
So
is your
I was
next?
not. Yeah,
Hmm.
my next is Tuesday 7 to 9.
Okay, 7 to 9
So
in the evening.
in the evening, yeah, yeah.
Okay, okay.
So maybe I have to reschedule the next week.
Uh,
The, only 1 week I have to reschedule because I am heading home that day.
hmm.
So I will be on a train. So better
Okay,
to reschedule.
okay. And how do you
I,
find the problems?
yeah, these are very interesting. So, I mean, there are some things for me to learn also because the minimal rings, those things I forgot. It's nice that I am recalling those things.
Okay, good.
I was not aware that most of the people who are joining are not familiar with commutative algebra or ring theories like Euclidean domain,
But
PID.
I'm not. I don't want to discourage them. But what is the aim? What do they want to do after? I mean, attending this course.
Yeah, because last time in last year I was also TA for your course.
Yes.
So that time I saw that some of the people were from maybe doing PhDs from triple IITs or NITs,
No.
uh, or like trying to crack some exam.
Mm.
And those have natural motivations with them. But
Mm.
yeah, if some of them wants to learn and recall those things, so that will
Yeah.
also be.
Yes, yes, yeah. Anyway, so uh, any more questions?
Uh, Pardon, sir.
Yes, please.
Uh, I don't have the question. Actually, why I have joined personally,
Yes.
because when I have gone through the this number theory courses, so its application
Give me one example. Which course? I mean, when you say number theory courses, so it appears
by
that.
okay Neptal number theory through Neptal courses only through
Hmm.
Sripad sir from IIT Bombay. So
Shripad, right?
Sripad, yeah,
Hmm.
yeah, sir.
Yes.
So very nicely he has explained. So there, what he used to solve the questions. So mostly he used to take the help of ring theory and field theory and group theory. So
Hmm.
actually, I did my MSc in 2000. Actually, 20 years already passed, and I didn't get the platform to study because there was no at my time there was no internet classes and no such facilities were there so that I can learn more. But actually, I wanted to do PhD and research in my subject, but I didn't got the opportunities due to financial
Oh,
problem and some issues also. So
okay.
now, just now 3 4 years, I've got the job now because
Hmm.
actually I was lacking in the concepts. But still, I like this math because there is a beauty to see. Actually, what I see, once you understand, once you start understanding, so you start seeing the insights that what is the beauty in the subjects. First
Yes.
of all, there we need one person who at least who explains the basics. But
Hmm.
in our college life, just what is there the teacher used to? I'm not blaming them. Actually, there is a lot of hectics because there are not so subject masters. So means the teachers are not available at that time also because very rarely the person actually understands the subjects.
Hmm.
Everyone wants the job, but actually, how many of them are understanding? This is the thing. Most of the people start just learning the things and start giving the same thing as it is. I have seen the beauty of this topic algebra because everywhere it is applicable, sir. Like whatever the so far the concepts I came across, whenever we are solving the reducible polynomial or maybe we are seeing the number of solutions. So there everywhere the ring theory, group theory, field theory. Because now because at that time I was not realizing, but what I am understanding that actually it is nothing else, but it is just the addition, subtraction, and division we are again we are studying like graduation and MSc. What I see that is now it is a LKG class for a student because I have to redefine from the beginning. But main thing is we have to understand that part. That's why I have chosen this course uh, because
What
there are a
about what about
lot of
linear
more things
algebra?
to explore.
What about
Linear
linear
algebra,
algebra?
I've understood very thoroughly, and I think Artendu sir was there, ISC Bangalore, one sir and one Mr. Ashok
Who?
and two instructors we have got. And actually I was knowing zero in that. I don't have the concept of linear algebra at all because I've done in my graduation, but still I was not understanding the what is eigenvalues, eigenvector, what is there also they have the spectrum of the things, then uh, number of solutions and then its application. Very
So
well they have
did you
explained.
attend NPTEL linear algebra course?
Yeah, I've got 91% in that. I've given the exams
Who
also.
were the instructors?
Artendu sir and Ashok Rao
From where? Where were they
from
from?
ISC Bangalore only. IIC Bangalore.
Can you tell me the name again?
I think Artendu or Ashok Rao. Ashok Rao.
I don't know
Professor
any.
Ashok Rao.
I don't know any Ashok Rao
Uh,
from
uh,
IISc Bangalore.
yeah, this was IIT Madras. I've got the certificate also. It is there. And
Okay.
Mr. Artendu something name was there. Anand. So
Okay.
actually, I'll clear my basics, but still I'll go through this. I know that this is more advanced than the basic group theory. and field theory. So I'm going through the course. So thank you, sir.
Okay. Yes, if anybody else have question?
Sir, I'm Vijay.
Vijay.
Sir, it's a little vague question, but I wanted to know your insights.
Yes.
Sir, in linear algebra, when we have a system of linear equations, so
Yes.
they represent some spaces and subspaces, and we try to see their intersection. The solution set is the common set of points
Hmm.
in those subspaces.
Your
So,
voice is splitting, Vijay.
I'm
Can you
sorry.
repeat your question?
Yes, sir, am I audible now?
Yes.
So when we reduced one system of linear equations to
Hmm.
another system of linear equations, so
Hmm.
geometrically the subspaces changed, but common solution are still same. Subspaces changed; they are not same. When we the elementary operations when we defined on them,
Yes.
then the subspaces change, but the common solution remains same.
What subset it change? Which subset?
The subspaces. I'm saying
Subspaces. So
yes,
which
geometrical.
subspaces?
Suppose ax like 2x plus 3y equal to 0, 1 subspace of
Hmm.
R2, and another equation if I say 3x plus 4y equal to 0, another subspace, and if I
Hmm.
row reduce it to semicolon form and the corresponding system when I see, then
Hmm.
those two lines are different from these two. So the subspaces are geometrical, they represent means like
No,
in
you
art.
are mixing up. You are mixing up. So when you have two linear equations, you
Yes,
perform some operations, no? Row operations, elementary row operations.
yes.
So did you check that when you perform the linear, uh, when you perform the elementary row operations, the solution set doesn't change?
Yeah, solution set doesn't change,
Did you
but
check
that
that?
no, sir, solution space doesn't change, but
Why?
individual
Why? No, why?
because algebraically we checked if any solution in the first system satisfy the second, and these two are equivalent. Conversely,
Okay,
this
let me ask
elementary
you
operations
concretely.
are
Suppose
invertible.
instead of row operations, you make a column operation.
Yes,
Then
still
the same statement is true or not?
yes, still are same because column operations are also invertible.
See, I will give you two equations.
Okay,
X,
sir.
x equal to 1 and y equal to 2. If you make a row operations, if you make a column operations, what happens? See, okay, let me just say that find a counterexample where you have two equations in two variables. If you make a column operations, the solution set doesn't remain the same.
Okay, sir. I'll try to think, sir.
You check this, and
Okay, sir.
then the new thinking will should come in for you that why does it not change for row?
Okay, sir. So,
Once you understand this,
hmm.
then you will start understanding elimination process and why is it called elimination.
Okay.
Okay.
So, sir, if we general not in generalize, but if we take degree two equations, so
Why
does there
degree
exist?
two? We are only talking about linear right now.
Yes, sir. So if we jump, like if we go to degree two, then is there any elementary row operations or and not elementary row operations? I'm saying like when we substitute a variable of one equation to
See,
another equation.
the moment you go on to degree more than degree one, even for one equation you will have problem.
Yeah. So, sir,
Leave
I'll
alone,
try to
leave alone the
explain
bunch. See,
except on this. Yeah.
if your equation is x square plus 1, what are you going to do? See, the whole problem is you want to find the solutions.
Yes.
So what are you going to do if over real numbers or over rational numbers, x square plus 1 equal to 0? If you want to get the solutions here, then the problem will start coming.
Yes. Actually, sir, my question is like, if we have a two equation in degree 2,
You take two equations into variables, x square plus 1 equal to 0 and y square plus 1 equal to 0.
0.
See, that is where you have to generate your own questions to understand. All right. So, any other question?
Hello, sorry to interrupt, sir. Myself Bharat from NPTL. We have other session at 4 p.m., sir. So please
Okay,
come.
okay. Sorry. So I was late now, so that's because I had some problem with my computer. Okay. Shall we close down? Siddhi has gone. Siddhi, shall we close down?
Yes,
Uh,
sir. I mean,
sir, next. Hello.
Sajinder, we are
Thank you,
getting
sir.
late today.
Yeah, thank you. I'm saying, sir, thank you, sir. Sir,
Okay.
actually, we have got the opportunity to have even a drop of knowledge from you. It's mean a lot for us, sir. It's like just seeing everything here. And
Okay.
thanks a lot, sir. Thank you. Good day, sir.
Okay.
Thank you, sir.
Okay,
Thank
then we close down Siddhi and
yes, and if they have any doubt, they can always ask in the discussion forum, and we will
yes,
respond
yes,
to.
yes,
Yes.
yes, yes. Okay, who is the NPTEL IC? Bharat.
Bharat,
Bharat,
yes,
no?
sir. Yes,
Bharat,
sir.
we close down now.
Okay, sir.